Hi everyone, welcome to SriSai online training. So today in advanced Python programming, we are going to discuss the following topic: object-oriented programming in Python, object-oriented programming principles, classes and objects in Python programming, constructor in a class of Python programming, variables and methods in a class of Python programming, and self variable in a class of Python programming. So coming to the first topic in advanced Python. Okay, so advanced Python, first topic is object oriented programming in Python, OOP. So OOP stands for object oriented programming. So what is this object oriented programming? Okay, so object oriented programming means it is a concept or it is a subject based on real life situations or objects. Okay, so real life situations or objects used in real life. Okay, so in real life we use many objects. For example, we use book object, we use bottle object, we use pen object, fan object, table object, etc. So the programming which is based on real life situations or objects used in real life is called as object oriented programming. Okay, so it is a programming based on real life scenarios or objects, and it is called as OOP, object oriented programming. Okay, right. So in object oriented programming we have different principles. Okay, so these principles define real life situations. Okay, so principles of OOPS. So here principles means real life situations. Okay, so principles means defining real life situations. So what are those real life situations which are defined by OOPS, object oriented programming? First one, abstraction. Second one, encapsulation. Third one, inheritance. And fourth one, polymorphism. So these are the four basic principles of object oriented programming in any programming language: C++, Java, .NET, Perl, Python, etc. Okay, so first one is abstraction, second one is encapsulation, third one is inheritance, and fourth one is polymorphism. Right, so this is what is object oriented programming. So concepts based on real life situation, programming based on real life situation is called as object oriented programming. So we have four principles of OOPS which defines real life situations: abstraction, encapsulation, inheritance, and polymorphism. Right. So coming to the principles of OOPS, the first principle of OOPS is abstraction. So what is abstraction in real life situation and how this is done in Python programming? Okay, right. So abstraction means hiding unnecessary things in a product and providing only necessary things to end user in a product. Okay, right. So for example, let us take pen. In pen, what is hidden? Okay, ink, refill are hidden. Okay, and what is exposed to the end user? Okay, so body, cap, nib for writing. So hiding unnecessary things and exposing necessary things to the end user is called as abstraction. Pen. Next, fan. So in fan, what is hidden? So what is hidden inside a fan? Motor, copper windings, okay, copper wire, etc. And what is exposed? Body is exposed, uh, and then fan wings are exposed. Okay, so this is what is hiding unnecessary things, exposing only necessary things to the end user in a product. Let us take mobile phone. So in mobile phone, what is hidden? So basically, battery is hidden, motherboard is hidden. Okay, next, what is exposed? Display is exposed. Okay, buttons are exposed. So hiding unnecessary things in a product and exposing necessary things to the end user is called as abstraction. Okay, now how this is done? Abstraction is done in Python program. So in Python program, abstraction is done using, okay, access modifiers. So access modifiers means like private, public, protected. Next, abstract classes and interfaces. So these are the three concepts using which we can implement abstraction in Python programming: access modifiers, abstract classes, and interfaces. Okay, all of you? Right. So coming to the concept of encapsulation in object-oriented programming. So in real life, encapsulation says that every product has two things. One, data as input. Two, functionality as behavior or usage of the product. So data, functionality. So data is input, functionality is usage. For example, if we take pen, so what is the data we give to the pen? Okay, so input. So what is the input we give to the pen? So we give something like blue ink. Okay, blue color ink. Okay, this is the input. How much ml? 2 ml. So 2 ml of ink. So this is the input, blue color ink, 2 ml. Right. So what is the usage functionality of a pen? Writing on a paper is the functionality or usage of a pen. Similarly, fan. So if you take fan, what is the input we give to the fan? So power. So power supply is the input, or we also give speed. 1, 2, 3, 4, 5. So based on that, what is the use or functionality of a fan? Okay, so air circulation is the usage of a fan. So it will rotate, okay, and give air circulation. Speed 1, speed 2, speed 3, speed 4, speed 5. So data as input, functionality as usage. For example, if you take a mobile phone, what is the input we give to the mobile phone? So we should give power. Okay, right? So for example, we give input something like phone number. Okay, when you give input for phone number, what is the usage? Making calls or sending messages. So this is what is the usage of mobile phone. So every product has two things: data as input, functionality as usage. So in Python program, how this is done, that is important for us. Okay, so in coming to the Python programming, it is done with classes and objects. So in today we are going to discuss about classes and objects. So coming to the concept of inheritance in object-oriented properties programming. So inheritance means getting properties and functionality from existing product into new product is called inheritance. For example, let us take iPhone 9, iPhone 10. Okay, so iPhone 9 is the existing product. Okay, right, and iPhone 10 is the new product. Assume it like that. So existing product and new product. Now in existing products, let us say that you have 2G technology, 3G technology and 4G technology. So these are the three technologies which are there in existing product. So this 2G, 3G, 4G are inherited to new product also. Plus in new product we'll have 5G. Okay, 5G, which is extra technology. So getting properties or functionality from existing product to new product is known as inheritance. And in new product we can have extra functionality and extra properties also. Okay, so in new product we can have extra, okay, extra properties or functionality. So this is what is inheritance. So coming to Python programming. So in Python programming we are going to do inheritance with base classes and subclasses. So subclasses are more powerful than base classes in inheritance concept. So coming to the fourth principles of object-oriented programming, polymorphism. So what is polymorphism? Poly. So poly means many. Poly means many. So many means two or more. Morphism. So morphism means forms. So forms means behavior or functionality. So what is the definition of polymorphism? Okay, so existence of single product in many forms based on some condition is called as polymorphism. Okay, so existence of single product, okay, in many forms based on some condition is called as polymorphism. So let us take one real life example for this. H2O. So H2O, water. It has three forms. So first one is water. Second one is, okay, first one is something like liquid state. Okay, so second one we have solid state, and third one we have gaseous state. Okay, so liquid state, solid state and gaseous state. So these are the three forms of H2O. So how H2O is taking all these three forms? So based on some condition. So what is that condition? So that condition is temperature. Okay, so here temperature, which is degrees. Based on that, it is taking 3 forms. For example, water. So water is the liquid form of, okay, H2O. So next, ice. So ice is the solid form of H2O. Next, vapor or steam is the gaseous form of H2O. So in different temperatures, it will take different forms. So forms means behavior or functionality based on some condition, based on some temperature. So in Python programming, how this is done, okay? So coming to the Python programming, it is done with method overloading, method overriding, and operator overloading. And optionally, we also have constructor overloading. So 4 concepts to implement polymorphism: method overloading, constructor overloading, method overriding, and operator overloading. So for all these things, we have different chapter and different topics. Okay. So this is what is polymorphism. So one product in many forms. So now coming to the concept of classes and objects. Okay. So classes and objects in object-oriented programming. So in object-oriented programming, this concept is related to encapsulation. Okay, so encapsulation, okay, which is object-oriented programming principle. Every object has 2 things: data as input, functionality as usage. Okay, right. So in Python, everything is an object. And to create an object, we require a class. So class means model or blueprint before creating a object. Okay, right. So now, what is the definition of a class? So the class definition goes like this. Class is a collection of data members and functionalities. Okay, so data members or data properties means variables. Functionality means functions or methods. Okay, so class means data variables plus functions or methods. So this makes up a class. So we also have another definition of a class. Okay, so binding together. So binding together data properties and functionalities. So binding together data properties and functionalities into a single unit is called encapsulation or class. Okay, so now class. So class is a model or a plan or a design or a architecture or a blueprint before creating a actual object, and actual object is called as our product, which is used by the end user. Okay, so let us take one example for this. So house blueprint. So house blueprint is nothing but a class or model. So who will design this model? Civil engineer. Okay, right. Now for this class, okay, what is a product? So the product is constructed house is the object. Okay, or end product. So who will use this end product? User. Okay. So object is end product used by end user. So who is end user? End user is nothing but customer or client or humans. So class is a model, blueprint of a house. Constructed house is a actual product or object. Okay, and for one class we can create multiple objects. Okay, so for one class or one model or blueprint we can have multiple objects or products. Okay, so one model, multiple objects. So house number one, house number two, plot number one, plot number two, flat number one, flat number two, etc. So this is what is class and its corresponding object. Okay, right. So now let us try to understand how to define a class in Python program. Okay, so how to define a class? So to define a class we use class keyword. Example, class, class name, colon, and this is a definition of a class, intended definition of a class. Okay, so indentation is compulsory for class body, otherwise we'll get an error. So once again I'll explain. Class, class name, colon, body of the class. So inside the body of the class, first we are taking comments. So comments using triple single quotes, then followed by variables and methods in a class. So these are called as data variables. So these are also called as functions or methods in a class, or simply in a class we call them as methods. Okay, so inside a class, function is called as method. Okay, write down. So inside a class, function is called as method. Okay, so this is how we have to define a class. Okay, right. So let us try to take this with a small program. But before that, what is this docstring? So docstring means description of a class or comment. Description or comment. So what is the class? We are going to describe that, and it is not executed. And how to get the description of a class? We have to use class name dot double underscore doc double underscore. You will get the description of a class. And will we say help a class name, we'll get the complete description of a class. Okay, now for this we'll get complete description or definition of a class. And for this variable we will get only the comment which is used by the class name. So let us try to demonstrate this with a small program, student.py. So program to define a student class and print double underscore doc double underscore description of a class and then help student. So help function gives, okay, so it is a help function. So help followed by class name. So help function gives complete description or definition of a class including data variables and methods. So let us get back to the program. So program to define student class, student.py. So I'm taking class student, colon is compulsory. So what is the comment or description or doc string we are giving? Student class definition in triple single quotes. Okay, triple single quotes. And then I'm saying print student dot doc and help student. So save this program in your working directory and then come to the command prompt. So I'm going to save this in g:/ssot Python. I have created a new folder, advanced adv. Under that, programs, progs, OOP1, object oriented programming folder. Right, so py will say student.py. So first we got doc. So what is a doc? Student class definition. After that we got the help. So help for which class? Student class in module. Module means student.py. So every module is a main program. Okay. So under that we have class student, description, and then variables and methods. So we don't have any variables and method. We got inbuilt variables, dict variable and weakref variable. Okay, what are these variables? We'll discuss later. Okay, so this is how we have to get the description, complete description of a class using help function or help method, and only comment or doc string using student doc double underscore doc double underscore. So coming to class with data variables and methods. So how to define variables and methods in a class? So basically in a class we have data variables or data properties three ways: instance variables, static variables, local variables. And coming to the methods, so methods in a class are also of three types: instance methods, class methods, and static methods. So as of now we are going to discuss only instance variables or object level variables and instance methods or object level methods. Okay, right, so let us see this in the form of a program first. Okay, student1.py, program to define student1 class with variables and methods. So this is the definition of a student class with variables and methods, and next we'll see how to create an object. Okay, so first we'll go to student1 class. So this is program to define student1 class with variables and methods. So this is a class definition, class student1. So student1 means it is not the first student, it is just the class name. Okay, right. So inside this class, first we are taking doc string or comment or description, student1 class definition. Okay, so under this I'm taking one special method. So define double underscore init double underscore. It is a special method known as constructor, and for this constructor I'm passing one input parameter self. So self indicates current object. Okay, right. So this is a special method known as constructor. So what is the use of constructor? So constructor is used to declare and initialize your data properties or variables of a class. Okay, so self dot roll number. So for current object, what is the roll number? 1001. So self dot name, for current object name is Sai. Self dot height, for current object what is 6.0. So self indicates current object. Okay, right. So self variable is current object. So how to create the object, we'll see that one also. Okay, right. So any object which is used for student1 class has three data properties: roll number, name, height. Now we'll take one more method, definition, display method, and for display method also we are taking self variable as input parameter. Okay, and we are printing self dot roll number, self dot name, self dot height. Means for the current object we are printing roll number, name, and height. So whatever is the current object which is using constructor or display method, for that self means current object roll number, name, height, and print it. So this is how we have to define a class with variables inside a constructor and display method to display those variables data back to the user. Right, so now class is ready. We have to create the object. Okay, right? So class means model is ready. So now model is ready, and now we have to create object. So object means end product. Okay, so class model object end product. So how to create a object? Okay, right. So what is a definition? So definition goes like this. So object is instance of a class. It represents state and functionality of a class. So object is instance of a class. It represents state and behavior of a class. So instance means one individual unique unit or end product. So one individual end product, one object. Okay, so they are physical units of class. So physical units means physical end products of a class. Okay, right? And here what is state? So state means data properties or variables. And what are behaviors? So behavior means methods inside a class. So this is what is object. So object is nothing but a instance of a class which represents state and behavior of a class. So state means data properties and behaviors means methods or functionality of a class for that particular object. Right, so now let us try to understand how to create a object. So now syntax. So syntax for creating objects. Very simple. Object reference variable is equals to class name circle brackets. Okay, class name circle brackets. So for student1.py class, the object is created like this. S1 is equals to student1 constructor. Actually this circle bracket indicates constructor, which is init method. So similarly I can take S2 is equals to student1 class constructor. So here student1 means it is not first student, it is just a class name. So how memory is allocated here? So in memory, S1 will be pointing to, okay, object. So this object contains roll number, name, height. Okay, similarly S2 object. So S2 object will be pointing to actual object in memory, roll number, name, height. Okay, so note. So object reference variable. So what is this object reference variable? S1, S2 is a variable which refers or points to actual object of a class in memory. So this is the actual object. Okay, this is the actual object, this one. And for this actual object, the reference is S1. So the reference variable is S2, and this is the actual object in memory. It is a pointer to that. Okay, and using this actual object, okay, we can access, using this object reference, we can access data properties and methods. So how to access, okay, data properties and methods? It's very simple here. So using dot operator, we can access class members, variables and methods. Example, s1.roll number 1001, s1.name sci, s1.height 6.0. So print s1 details, s1.display. It will display roll number, name, height using display method. Similarly, we can also take s2, student1 object, s2, s2.roll number 1002, s2.name ram, s2.height 5.6. Print student1 class. So we can take here student1 class. Here also student1 class s2 details, s2.display. So for single class, we can have multiple objects. So let us try to do this in the same program, student1.py. So get back to the program. Right, our class is ready. So inside this class student1, we have description of the class, special method, constructor, double underscore init. So inside the constructor, using self variable, we are initializing the data members, roll number, name, height, and another method, display method, using self variable, we are displaying roll number, name, height. So now let us create the object. S1 is equals to student1 object. So when you call student1 object, so this circle brackets, it is a function call. So it will automatically call init method. Okay, so what is the object S1? So S1 dot roll number 1001, S1 dot name sci, S1 dot height 6.0. So this will be printed. Okay, this will be stored in S1 object. Okay, right, so it goes like this here. So S1 object in memory, roll number. So roll number 1001. Next, name sci, height. It will take 6.0. Okay, so this is how memory is allocated for student1 class S1 object. Okay, right, so in memory S1 is pointing to this object. So how did we get this? It is because of this special method. So init method is automatically called when we create the object of a class. Okay, similarly for S2 also, when we create the object of the class, init method is called, and then we will get these values. S1, now here it is S2. So for S2, again 1001, name sci 6.0, because for S1 and S2 both same constructor is called. So after that, print student1 class S1 object S1 dot display. So S1 dot display, so self indicates current object, roll number, name, height. 1001 sci 6.0. Similarly, s2.display. For this also self. So self is s2 now because the current object is s2. It will display 1001 sci 6.0. So save this program, come to the command prompt, and then run student1.py. Okay. So s1 object 1001 sci 6.0, s2 object 1001 sci 6.0. So we are getting same data for two student objects. Reason, because when object is created, constructor is called automatically. So in constructor we are having static values. So that's why for both the objects s1 s2, when we say display method, okay, we are getting the same values. So now let us go for, okay, individual variables, values and display method. So second case goes like this, right? So let us put a comment for these cases and uncomment this, right? So now, so once again let us create object s1 is equals to student1 class constructor. So actually this circle bracket indicates student1 class constructor, which is init method. Okay, so init method is called automatically. I'll write it here, underscore underscore init method is called automatically when object is created. So s1 dot roll number 1001, s1 dot name sci, s1 dot height 6.0. So print student1 class s1 details s1 dot display. So now it will give 1001 sci 6.0. Now let us create s2 object, right? So s2 object for class student1, and this is a constructor init method, special method which will create and initialize your data properties, roll number, name, height. For which object? s2 object. So now we are storing different details now. Roll number 1002, s2 dot name ram, s2 dot height 5.6. So print student1 class s2 details, s2 dot display. Right, so save this program, come to the command prompt and run. So for student1 s1 object 1001 sci 6.0, for student1 class s2 details are 1002 ram 5.6. right? So here very important point, it goes like this here. Note, so when object of a class is created using class name, okay, example, so example goes like this, s1 is equals to student. Okay, so here underscore underscore init, which is constructor or special method, is automatically called. Okay, so what is the use of constructor? So constructor defines data properties or variables and gives initial values. So like in our program, our constructor is giving roll number, name, height. So defining and initializing values for our s1 object and s2 objects. So this is how we have to define a class with variables, methods and special constructor using self variable. So coming to what is self variable. So self variable is a special variable available for every class separately in Python. So what is the use of self variable? So self variable refers to current object under execution. Okay, so self means current object. So if the current object is S1, self is S1. If the current object is S2, self is S2. So this is same as this keyword in Java. Okay, so using self variable we can access instance variables and instance methods. Okay, right? So example, so self dot roll number, self dot name, self dot height. Okay, so similarly, so this is how we access the instance variables, and then instance methods, we'll see it later. Okay, right? So now one important point here, note, this is compulsory, we have to follow it. Self should be first parameter in constructor or method. It should be first parameter in constructor or method. So we are taking init constructor, so self should be first input parameter. In display method also, self should be first parameter. Now for example, if you're taking other parameters, for example, I'm taking show method. So I have to take self first parameter, after that I have to take other variables a comma b. Compulsory it should be the first parameter, otherwise we'll get a error. So this is what is all about self variable, which refers to current object under execution in a Python program. So now coming to the concept of constructor in Python programming. Okay, so what is constructor? So constructor is a special method in a Python class. What is the name of the constructor? Underscore underscore init self. So self indicates current object. So constructor is executed automatically when object of a class is created. Example, S1 is equals to student. So this circle bracket indicates this init constructor. So what is the main purpose of constructor? Using constructor we can declare and initialize instance variables. Instance variables means variables to the object, like roll number, name, height. So as per our requirement, we can declare and initialize variables inside a constructor. And constructor is executed automatically once per object creation. So it is executed automatically once per object creation. And constructor takes at least one parameter, self. So self means current object. Example, so current object means S1 or S2. And it is not compulsory in a class. Okay, so if you don't give constructor, then Python provides default constructor. Okay, so Python provides default constructor. Example, def underscore underscore init self. So this is a default constructor with empty body, nothing inside the body, no data members, no methods, no data properties. So this is what is all about constructor. Special method, a double underscore init with self variable executed automatically when object is created. Main purpose is used to declare and initialize instance variables like roll number, name, height, executed automatically once per object, takes at least one parameter, self. So self indicates current object. It is not compulsory, it is optional. If you don't give, Python provides default constructor. Okay, right. So let us try to work with constructor with self and default values, constructor with self and given values, constructor with self and other values, other input parameters, and constructor with other input parameters. So let us try to demonstrate this in a program. Student11. So get back to the program. So program to demo a class with constructors. Okay, right. So first let us take class definition. So class student11. So here student11 means it is not student level, it is just a class name. So first we are taking description of a class, student11 class definition, and then we are taking a constructor with self as input parameter. So inside the constructor we are declaring variables self.roll number, self.name, self.height. So initial value for roll number is 0, name empty, and height is 0.0. Now let us create an object for this class. Right, so we also have display method inside a class. So display self. Self means current object. So current object dot roll number, name, and height. So let us create an object. All the cases one by one now. Height. Okay. So first case goes like this. S1 is equals to student11 object. So S1 object is created. Automatically it will go to the constructor. S1 dot roll number 0. S1 dot name empty. S1 dot height 0.0. Right. After that we are calling display method S1 dot display. So it will go to the display method. So self means S1. S1 dot roll number 0. S1 dot name empty string. S1 dot height 0.0. So save this. Come to the command prompt and run it. Student11. So 0 empty string 0.0. So what happens if you don't give this constructor? Let us check it out. Put comment for this, save this, and run. Now if you see here, student11, when you are calling the display method, in display method it is saying that roll number, name, height are not defined. Okay, because we did not give them in the constructor. So it is giving problem with display method. So better to use constructor whenever you are working with display method. Okay, so now let us use the second constructor. So the second constructor goes like this. Define init constructor self current object. So self dot roll number 1001, name psi, height 6.0. Now same object. Let us create the same object dot display. So save this and then run. So now we'll get 1001 psi 6.0. So this is defined inside the constructor. Okay. Right, now let us create another object here. Now this object with parameters. So I'm creating S2 object for student11 class and I'm passing 3 input parameters 1002 RAM 5.9 S2 dot display. Now let us take this constructor now, second constructor. Right. So define init constructor. So self means current object. We are passing 1002 RAM 5.9. So initialize 1002 to roll number, initialize RAM to name, initialize height to H2 height 5.9 or 5.6. So save this and run. Okay. So init is missing with 3 position parameters. Okay. So here what we'll do is first we'll put a comment for the previous constructor. Right. And then let us put comment for the previous case also without parameters. Now just only run with 3 parameters. So save this, run. So 1002 RAM 5.9. Right, so now let us go for the third type of constructor. So in the third type of constructor, what I'm going to do is I'll take data variables and input parameters with same name. So define init constructor self current object input parameters roll number, name, height, and data properties are also same name. So self dot roll number, self dot name, self dot height. So input parameters are initialized to roll number, name, height. So we can also have same name, no problem. And then display method. Right. So let us create the same object with a display method. So save this and run. So 1002 RAM 5.9. So for constructor, we can give user defined variable names also, RNH. We can also give same names as that of the data properties. So self dot roll number, self dot name, self dot height. So data properties and variables input parameters can be same name. Right. So finally, yes, this is how we are supposed to work with. Okay, this is already we have seen accessing class members. Okay, using object reference variable. For example, if you see this, I'll take another object s3. Okay, student11 object. So s3 dot display, s3 dot roll number will take 1003, s3 dot name, I'll take it as Ali, s3 dot height, I will take it as something like 5.9, and I'll say student s3 details and s3 dot display. Okay, right. So first we have created the object without input parameters to the constructor, second with input parameters, and third one we are initializing the properties using, okay, so here we are initializing the properties using the default constructor. So let us go to the default constructor. So this is our default constructor here. So in default constructor, we are initializing the variables 0, empty string 0. So for S3 object, default constructor is called. So save this, come to the command prompt and run. Okay, so missing parameter. So what we'll do is we'll put a comment for the second case. Right, so save this and then run it. Okay, still we are getting an error. Acha, we have to put a comment for this constructor also, because it will take the latest constructor into consideration. So only one constructor, one method. So initially we have 0, empty string 0.0. Now we have 1003, Ali 5.9. So this is how we are supposed to work with constructors with parameters and without parameters. They are automatically called when object is created. So that is what is all about today's session in advanced Python programming, object-oriented programming, object-oriented programming principles, classes and objects, constructors in a class, variables and methods in a Python class, and self variable in a Python class. So right guys, thank you for watching and listening to this session. Have a nice day.